Hi everyone. Today we're going to take a quick look at the SIP register method. You may recall that SIP has 14 different methods and a number of response messages that are sent in response to a method. One of the most common SIP methods that you will see in your Wireshark captures or your protocol analyzer captures is the register method. This method is used by SIP user agents when they register with the SIP server or IPPBX, providing location and authentication information. Let's take a look at this SIP register request coming from IP address 192.168.2.2 and going to the server, the IPPBX, at 192.168.2.4. So when we look at Wireshark, we see a typical IP packet using Ethernet in the local area network. SIP messages can be transmitted over UDP or TCP. If we look at this SIP message, it is being sent over UDP, User Datagram Protocol, destination port 5060. When you look at the IETF, or the IANA I should say, port number assignments, you will find that port 5060 in UDP as well as in TCP is assigned as the registered port number for SIP. SIP-S, which uses transport layer security, is assigned port 5061. In this example, the user agent, that is to say the SIP phone, is also using, or in fact is using port 59,560. This device does not need to use port 5060 because it is the initiator of this message. It is sending up the SIP request to the server. The server will respond to whatever port number is listed here in the source port. Let's open the SIP message and take a look at the details of a SIP register. As in all SIP methods, we see a request line, a message header. There may also be a third field called the message body. In this case, the register method does not have any information in a message body, and so we see the request line and the header. Let's open the request line. In the request line, we're told which specific SIP method is being used, in this case the method register. Methods are always written in capital letters. And we see the request URI, SIP:, and the socket associated with the server's SIP service, 192.168.2.4, and then the port number 5060. Let's open the message header. I'm going to make this middle section of Wireshark a little bigger by dragging this screen up and dragging this screen down. In a SIP message, we will always see the via field. The via field tells us, or can be used, is used, to build up a path of SIP servers that the SIP message passes through. The via field normally starts with the connection or the socket information associated with the user agent. If this SIP message was to pass through 2, 3, or 4 SIP servers, each SIP server would add a via field to the message header. Note that the first SIP server, the IPPBX that we are in fact registering with today, normally will strip or remove this via field coming from the user agent to hide this information from ongoing transmissions to additional SIP servers. The next field we see is in this example, is the maximum forwards fields, set to 70. The default configuration for this field in RFC 3261 is 70. This field tells the SIP server whether or not the SIP message can be passed to another SIP server. Each time the message passes through a SIP server, this field is decremented by 1. In many ways, it is very similar to the IP header field. Let's go back and open that for a moment, called time to live. The two fields perform a very similar function. The time to live field, you may know, is decremented by 1 each time an IP packet passes through a router. The maximum forwards field is decremented by 1 each time the SIP message passes through a SIP server. You may ask yourself, why do I need maximum forwards if I already have the time to live field in the IP header? That's a good question. If you stop and think about it for a moment, imagine the SIP message being transmitted over UDP, over IP, to the SIP server, and then being sent to another SIP server, proxied, we say, to another SIP server, to reach the final destination. The SIP server will have removed the Ethernet header as well as the IP and UDP header. It will then prepare the SIP message using a new UDP and new IP header, effectively resetting the time to live field. So it is only through the maximum forwards field that we are able to track this SIP message as it moves through multiple SIP servers and potentially avoid a loop. The register includes contact information to and from. These fields are common to all register methods, all invite methods. The contact field provides us with information on how to reach the SIP user agent in SIP. So SIP : SIP username at the current IP address where the user agent is located, :59560. This says if you wish to send SIP messages to me, SIP methods or responses, send them to this socket, and this is my SIP username. Note that the to field and the from field are essentially identical. This provides the SIP user's contact information, SIP address information at the SIP server. In this case, SIP : 221 at the server's IP address and the server's port 5060. Call ID is a unique number used to track all the SIP messages that go together in this particular SIP dialog. Call sequence tells us how many times the register method has been attempted. The expires field, in this case, says that this register will expire in 120 seconds. The allow field lists the supported SIP methods that this SIP user agent, this SIP phone, supports. As you can see, it supports invite, acknowledgement, cancel, options, buy, register, subscribe, notify, refer, info, and message. Total of 11 of the 14 possible SIP methods. It's not unusual for a SIP user agent to support a subset of the available SIP methods. So for example, in this case, the method practical acknowledgement, is not supported. We see the user agent field telling us information on this particular device. In this case, it was a 3CX phone. And we see content length 0 telling us that there is, in fact, no message body. So, this SIP register method is sent from the client device to the server. in an attempt to register. The server responds with this message: 407 Proxy Authentication required. In effect, this is an error message, the 400 series message. You may be familiar with 404 error messages in HTTP. Let's take a look at this 407 proxy authorization required. We note that the SIP message is using UDP is coming now from source port 5060 to destination port 59560. The server knows to send SIP traffic to the SIP phone's IP address and this port because that information was provided in the SIP register method. Let's take a look. Response messages do not have a request line, they have a status line. And in the status line we can read the status code, in this case an error code 407. In the message header we see the original via field, the original to and from field, the original call ID field, and register field. The user agent field has now been updated to the SIP server, or IPPBX. The content length in this message is also 0. We do see one new field though, Proxy Authenticate. This field tells the SIP phone how to proceed with the authentication process to provide the server with username and knowledge of, or confirmation of knowledge of the password. The servers responded saying you must use a digest, or in this case a hashing algorithm known as MD5, Message Digest 5. The servers provided the nonce, or large random number, nonce means nonsense number, to be used in the MD5 process. The SIP user agent, the SIP phone now, responds again with a register method. If we open the message header, we'll see that it is call sequence to register. All the fields remain the same. However, one new field is added, Proxy Authorization. In the Proxy Authorization, we list the SIP username, the nonsense number that was provided by the server, and a hash, or response. The hash is calculated using the MD5 algorithm, the nonsense number, portion of the message, and the stored user password. This SIP message now arrives at the server, and the server responds with 200 OK. This 200 OK message, in response to the second register, allows the phone to proceed as a registered device at the, in this case, 3CX IPPBX. How was the server able to use the response, the hash response, to authenticate the user? If you think about authentication for a moment, the concept is that we do not wish to transmit information. We wish to confirm that it exists. Authentication algorithms are designed to accomplish the task of confirming information, not the task of transmitting information. We go back and look for a moment at the Proxy Authenticate in the 407 message. The goal of this algorithm is to ask the client device, the SIP user agent, to use its stored password to calculate a value known as the hash or response number. When that response is sent to the server in a second register message, the server proceeds to do the same calculation using the same nonsense number on the stored password for that user inside the server. If the two response numbers, the two hash numbers, are identical, then the server knows the client must have stored in it the correct password, and it provides the 200 OK response. At this point, the SIP user agent device is registered and can begin sending invite messages or subscribe or whatever methods it wishes to use. This has been a brief overview of the SIP register method requiring proxy authentication and the 407 status response used to provide the SIP user agent with the nonsense number and the request for an MD5 hashing algorithm calculation. We saw the transmission of a second register method, including the hash built from the password, the nonsense number, and additional data required by MD5, namely part of the message. We saw the server run the same calculation, calculate the same hash, and then allow the device to be registered. At no point was the password transmitted, only a derived value known as the hash, from which it is essentially impossible, extremely difficult in any case, to revert back to find the password. In effect, the password has been hashed or cut up, chopped up to such an extent that it is effectively not transmitted. It's not mandatory in SIP to require a hashing algorithm to authenticate a user password to allow registration, but it's extremely common. In fact, it's not unreasonable to require this same authentication algorithm to run on all SIP method transmissions to the server. Typical default configuration would see authentication requirements for the register method, authentication requirements for all invite methods, and perhaps the remaining methods would be allowed to be transmitted without requiring authentication. Thank you and have a great day.